Section 1.7, number 22. We're given two functions. In this case, f of x is 9 minus x squared for x greater than or equal to 0. And g of x is the square root of 9 minus x. And we're told to show that f and g are inverse functions algebraically. And then we're going to use a graphing utility. I'm going to do a graph and show that f and describe the relationship between f and g. And what we're going to see is that these things are flipped across the line y equals x, and think of it as an origami folding over the line y equals x, and we'll see that on the next page. So if we want to test to see whether or not these things are inverse functions, we have to do a composition, right? So let's first compose f and g. Okay. So f composed with g means we take the entirety of g and stick it in where x would be, right? It's the magic box idea. So this is 9 minus, instead of x, we have the entirety of g, square root of 9 minus x squared. Okay. Now, fortunately for us, squares and square roots play nice. They undo each other. So we're going to get 9 minus x. Okay. Now this minus we can distribute. This minus makes that a minus 9, and minus a minus x makes that a plus x. The positive 9 and the negative 9, we're adding and subtracting the same thing, so they'll cancel, leaving us with just our x. Okay, so f of g is good. Okay. Now what about g of f? All right, so now in this one, we start with our g, and we stick the entirety of f where our x was. Okay? All right, now, again, we have this minus outside of this parenthesis, so I want to distribute that minus. 9 minus 9, so the minus and the plus makes that a minus. Minus and a minus makes that a plus. Okay? Adding 9 and subtracting 9 cancels those out, leaving us a square root of x squared. Square root of x squared leads us to just x for our x being positive. Okay? Remember, the square root of x squares is the absolute value of x, but if x is positive, absolute value of x and x are the same thing. There's no negative to get rid of. Okay? So we are verified there as well. All right, now we've verified the fact that they're inverses algebraically. Now let's take a look at the graphs and see what we got. So here in this graph we have our f, which was our 9 minus x squared, and we had our g, which was the square root of 9 minus x. Okay. And when we look at this graph, I've added on the line y equals x to kind of make it clear what's happening here. These things are mirrored across this line y equals x. And one of the ways you can think about it is if I take the Cartesian plane and I fold it along the line y equals x, f and g will fold across on top of each other. Okay? So this line, the f, and that line, the g, right? If I fold it across, they have to line up on top of each other. It's kind of an origami problem at that point. Okay? So these inverses are mirrored across this line y equals x. The line y equals x is magic because if we interchange the roles of x and y, the line y equals x is the only line in the graph that is not moved. Okay? If I exchange y equals x here, I get the line x equals y, which is the same line. Okay. So that's the relationship graphically between these two functions. And this is a relationship that all inverse functions are going to have with each other. All right, so got a couple examples. Give those a look over, and good luck.